Hello everyone. So today we are going to learn about the transformation, which is very important in regards with JEE Advanced as well as Main. So why it is important is because just one example I would like to give before proceeding. This is very useful in area under the curve. So if you see question, they will ask you what is the area under the curve of x plus e whole power log e x plus e base e from x equal to 0 to x equal to 3, just for a random example I'm taking. Now how do you know how to draw this graph? But assuming that everyone knows how to draw this graph, I can just do the transformation of f of x plus e and get the graph for this. So in this way, and moreover greatest integer function, ceiling function, all these functions are important as well. So let us start. So I have considered one example. So this is a graph. This is a random graph taken. With regards to this graph, we are going to learn all the different types of transformation, as you can see, from A to J. Right? So this graph is for a function f of x, which is we are not defining right now. It's just a graph for f of x. Now let us see how to do this transformation. Now over here, what is happening? Here f of x plus 1 is happening. Okay. So whenever the transformation happens from f of x to f of x plus 1, considering an example, let us say f of x is x square, then f of x plus 1 is x square plus 1. Right, now how do we draw that graph? So basically what we do is we just shift the graph through 1 unit upwards. Why? Because if you consider f of x, then this is basically y. So what is happening? The value of y is increasing by 1. So of course, if it is increasing, of course it needs to go upward. So earlier the graph was, for example, this point if you take, if it has to move 1 upward, it will come here. If it has to move this 1 unit upward, it will go here. So basically everything will shift. So you can see this blue graph. This is the transformed graph, that is f of x plus 1. Now I think you got an idea how to do f of x minus 1. So in this, earlier let us say y was at 1, for example. Now the y will become to 0. So we will move it 1 unit downwards. And this is how the graph looks like. It's pretty easy over here. Right? Now coming to the next one, where f of x is transformed to minus f of x. Now to do this, what we do, we take the image of f of x in the x-axis. So in simple language, we consider the x-axis as a mirror. So how it will reflect or how it will give the image on the other side, that's what you're supposed to draw. So this will look like this with this with this. Then the black one is your old one. So this one image will be this one image will be this. So whatever is to the down will be reflected to the up one, and whatever is on the up will be reflected to the down. So this blue color graph is your transformed graph of minus f of x. Right, now let's come to this. And moreover, graphs on modulus I have done in a separate session, that is JEE session 1. In that, if you go through, you will get a better idea how to do modulus graph. Now these graphs are very common. When you will do calculus, you will understand the importance. They will ask you x square plus x plus 1 mod integral from 0 to 1. And if you know graph, it's very easy to do. That also we will be learning in the next session. So how to draw mod graph? Now in simple language, you understand, if f of x is x, then mod f of x is equal to mod x. So you know that mod will always give you positive value, right? So if this transformation, this is y, if it has gone to mod y, then of course the value should always be greater than or equal to 0. So if you understand, this transform graph will always be above x-axis. That much is the first understanding we need to have. Now what happens? Whatever it takes, for example, f of, over here, let us just assume this is 0.5. So at f of minus 0.5, it is taking minus 1. But now when you do mod f of minus 0.5, it will become mod of minus 1. So it will basically become 1. So now what happens is, in this case, whatever is below the x-axis, whatever is below the graph, that you have to take the mirror image and flip it up. Okay, so you don't have to flip the up to down, no, only whatever is at the bottom part, that should be flipped up. Let's go into the next one. Next we have f of x as f of minus x, considering an example. So I have f of x as 2x, so now f of minus x is minus 2x. Okay, another example we could take, f of x is sin x, so f of minus x is sin minus x. So I need the graph of this, but I know very well what is the graph of sin x. So with that, how to do? So first, of course, you will draw a graph of f of x. That's the given in the question. After that, what you will do is, you will take the image of the curve f of x in the y-axis as a plane. Right? So this is your y-axis as a plane, and you are going to find the mirror image of this. Okay, so in this, if you see, the pink color is actually f of minus x and the dotted line blue is the original graph f of x. Now you see what has happened. Basically, I have to take the mirror image with respect to y-axis. So whatever is here will be flipped here, and whatever is here will be flipped to the other side. So just telling you, earlier this was the graph on this side. Now when you take the mirror image, it will become like this. And all these three lines, it will be going over there. So this pink color is the graph of f of minus x. Next, coming to the next one. So one we just now did, f of x going to mod f of x. Now in this, f of x is going to f of mod x. There are two different things. Now in this, what happens is, just to understand with an example, f of 2 will be same as f of minus 2. Why? Because I am taking mod of that. Correct? So whatever is the image for the positive x coordinates will be this image for the negative y coordinate, in simple language. In this case now, so f of, let us take one example to have a better understanding. Let us say if f of x was earlier x plus 2. Now the transformation that I have done is, now this is the function that has become mod x plus 2. This is your function now. Now in this function, if you take the value at 2 and if you take the value at minus 2, it will still be 4 only for both. So what happens in this case is, whatever is the image for the positive x coordinate will be the image for negative. Now in this case, what we do is, we consider the y-axis as a mirror. You erase the graph, whatever was the original graph of f of x, to the left of the y-axis, like erase it completely. Whatever is the graph on the right side, that mirror image you will take. And this complete is the graph of f of mod x. Okay, let me take another example. Pretty common one. Let us say f of x is sin x. Okay, let's quickly draw the graph of this. This is the graph. Right? So what will be the graph of f of mod this? So it will be sin mod x. Now as I said, let me use another color for this. Now you just forget about the graph on this side, basically this thing. Now whatever is on the right side, that mirror image you take. So now it will come like this. So now the graph is this. You have erased the left side, and now the reflection of this is this. So this is the graph of sin mod x. Alright. Right. Moving forward. Next is when you multiply a constant with the function. So if f of x is sin x, then if I want f of 2 times f of x, so it will be 2 sin x. Now in this case, what happens, understand, earlier there was some y, now it is going to 2 times of that. So of course the value is increasing if y is positive. So what happens, it will expand along y-axis, right? That's what we say stretch. It stretches along the y-axis, right? And how many times it will stretch? Twice, right? Assume this was the point earlier, the black color is the old graph. Now this I have to expand. Okay, so it will go twice. So you see here, of course, so 0 times 0 is 0 only, it will be here. Now it was at -1. So double of -1 is -2. So it will come at -2. So this point will be stretched and automatically this stretching will happen. Similarly here, at -1.5 it was 1. Now it would be 2. So now this stretching will happen. And all this also stretched to 2 units. Alright. Next is now. So you see all the transformations I have included over here. Here it is 2 times of f of x. But now what about f of 2x? Let's see that as well. F of 2x, now let us see. Now try to understand what is happening. F of 0.5, which was the old graph, now the new graph should be f of 1 at the same value. Right? So you understand here. Earlier, this was 0.5. At this, the graph was something like this. This was the old graph, right? Now, if I put 0.5, what I am getting? F of 1. And what was f of 1 actually old? It was 1 only. You see the old black graph? At 1, it was 1. That means what? F of 0.5 should now be 1. Correct? Next, if you see, you have to basically, you see here, you have to shrink the graph 2 times along the x-axis. You have to shrink. So earlier, the graph was something like this. Now, at this point, if I have to shrink it, where will it go? It will go here. Isn't it? See, earlier, if I want f of -1, now that thing has become f of -2. What was f of -2 earlier? 0. So f of -1 will also be 0. Alright? You have to shrink it. Now next, coming to the interesting part, is greatest integer function. Again, there are 2 things, both we will cover. One is greatest integer function of this, another one is when x is at greatest integer. Both I will be covering in this. Let us start how to do this, which is little bit tricky, so I would like all of you to focus. So what you do over here is, first of all, you have to draw the graph of f of x, no doubt about it. Next, what you are supposed to do is, you have to mark integers on y-axis. Keep in mind, on y-axis. Over here, since the graph is very small and it is touching to maximum this and this, so I will draw these 2 lines along with this line. Don't forget this, because at 0 also, no, 0 is on y-axis, so of course a line should pass through this. So this and this, these are the 3 lines. Okay. Next, draw the horizontal line till they intersect the graph. For example, at this you can see all the intersection point, you mark it. At here, you mark all the intersection point. At here, you mark all the intersection point. After this, what you are supposed to do is, now draw a vertical lines from these intersection points. As you can see, I have already drawn. Right? This, it should go till here, as well as this green lines. Next, the final step is, draw horizontal lines parallel to the x-axis from any intersection point to the nearest vertical dotted line with blank dot at the right end. Okay, so it's like solid and right and blank. Solid, right and blank. Now see here. Also, one more thing I would like to tell is, there are 2 things you have to consider here. One is the graph where it is increasing. Basically, it's going something like this. And the graph where it is decreasing like this. In these 2, you focus what I am doing here. Now, let's start with this. So, this is the point of intersection, right? Now, you see from here, the graph is increasing. Up, it's going. Whenever the graph is increasing, where it is intersecting from there, solid, gone, blank to the next point. Now, you see what happens. Let me just draw one more thing here. So here it is intersecting here, here, here and here. Okay. From here to here, since the graph is increasing, from the point of intersection to the next point of intersection, because of course here the other line, no, they said till here you will draw like this, blank. Next, since the graph is decreasing from here, what you are supposed to do is, this circle is solid only, okay, at the top, no doubt, because that is an integer it's giving. From here, you will come down to the point intersection with the x-axis. There you will draw a solid line and then blank. Okay. Some people, what they will do is, I will tell, they will consider that even when it is decreasing, here it was touching, right? Here was the next point. What they will do is, they will do solid and hollow. That is wrong. When it is decreasing and increasing, there are two things that should happen, right? Now, when it is decreasing, it should be hollow and then solid. So let me just erase this one more time. Okay, let's go back again. So first one, since it is increasing, this was the first vertical line, second vertical line. From here, solid, hollow. And wherever solid is there, that will be solid only. You don't have to touch over there. Next, since it is decreasing, okay, since it is decreasing, what you will do is, now it will go ulta. So whenever it is increasing, you will do solid to hollow. But whenever it is decreasing, you will do hollow to solid. I hope it's making sense to you. Right? So what will happen here? This will be hollow to solid. Okay, I didn't put over there. Let me put hollow. Understood? Now next, again, since it is decreasing, so I'll just consider this. All the blue is the actual one. Now since it is decreasing, what happens? Remember, you will come here to the point of intersection, like the next integer line. Here, hollow and solid. Now since it is increasing, what should happen from here? Solid to hollow. Okay. I hope I'm making it clear to you. Let's go to the next one. Next one is again a very important one. First of all, let us understand, before doing all this, you should have learned the properties, greatest integer, fractional part. So what happens is, x is equal to greatest integer function of x plus fractional part of x. Right? Now what happens in for this is, basically I can replace this as fractional part of x. So I am doing the transformation of f of fractional part of x. Now in this, what happens? Very simple. Retain the graph of f of x, draw the graph of f of x. After this, what you do is, whatever is the graph of f of x between the interval 0 to open 1. That means 0 to open 1, whatever is the original graph. If you remember, this was the original graph, right? You don't worry about any part except for 0 to 1 part, this part. Okay? And this was the original graph actually. The same graph you will repeat for all the other intervals. Simple as that. Okay? Let us understand with this. I know the greatest integer is quite a problem, so I have come up with one more question. F of greatest integer function of x. Let's see. The first step is to draw the line y is equal to sine x. Of course, that all of you know, I hope. After that, you draw the horizontal line through the integers. Here, luckily, only 3 integers. This and this are there. The third step is draw vertical lines from the point of intersection. So, wherever it is intersecting, as you can see, you will draw vertical lines, right? Like this. And the final step is to draw the line parallel to x-axis from any intersection point to the nearest vertical dotted line with blank dot at the right end as shown. Now, one more thing I have included. In case of increasing, or else do what I am going to say right now to you. Let's come to here. I have drawn the graph. I have drawn the dotted line. Till here, I am quite sure you are okay. Now, how do you draw? Let's see. You see, this is increasing. Whenever it is increasing, solid to the next line hollow, and solid of course here. Solid will be always solid only wherever it is intersecting, you don't have to worry about it. Now it is decreasing. If it is decreasing from the upper line, I will come to the bottom line, the below integer, and from here I will do hollow to solid. Reverse, right? Next, again it is decreasing, so I will come to one below line, y-axis line. So it will be what? Hollow, solid. Now it is increasing, so it will be solid, hollow. Increasing again, so from here solid, hollow. Now it is decreasing, so it will be hollow to solid, decreasing. Come below, hollow, decreasing. Increasing, solid to hollow. That's what I have written here. Whenever it is increasing, from there only that point solid to hollow. But if it is decreasing, you will come one below line. From there you will do hollow to solid to the next point of intersection. And this is the graph for mod of sin x, as you can see. Okay. And if you want, you can understand also with an example. You just take sin x. Okay. Now I want to find this. Okay. So if I want to put sine, let us say 120 degree. You know what is sine 120 degree, right? It is 180 minus 60, and that is going to be root 3 by 2. So root 3 by 2 is 1 point something, so 0 point something. So of course it should give 0. Now let us see where is 120. So 120 is where? So 120 is going to be this is in this part. So in this part, it should give me 0 the function. As you can see, it's giving you 0 over there. Okay. With that understanding also we can draw, but this is much more easier. Now coming to the next one. These types of question, as you know, comes for JEE. Okay, right. Now first of all, before doing this, you should know what is the graph for this. Sine inverse of sine inverse, this is the graph. The black color is the graph for it. Okay. Now I want the greatest integer of that. Let us understand. So I have drawn the lines. Please go through it. This is pi by 2. At pi by 2, it is pi by 2. Okay, this is the graph. So of course pi by 2 is 1 point something. So of course the next integer will be above. So I have drawn the line through 2, through 1, 0, minus 1 and minus 2. And wherever it is intersecting, from there also I have drawn vertical lines, as you can see. Now you see, here it is increasing. Wherever it is increasing, I have not drawn the full graph, okay? I have just taken a part of it. Wherever it is increasing, see, here the point of intersection, solid, hollow. Solid to the next line, hollow. Solid, hollow to the next line, right? Now coming to down. From here it is decreasing. So what I will do, anyway, this is not an intersection point, so don't worry. The next intersection point is this in the decreasing part. So you will come one below line and then hollow to solid. One below, hollow to solid. One below, hollow to solid. Now again increasing. This is the point of intersection, solid, hollow. Solid, next one will be hollow. So I hope this is pretty clear to all of you. So I would like to proceed with the next graph that I said. So we will be doing two things, greatest integer of f of x and f of greatest integer function of x. Now let's come to this one. Now in this what we do is, in this we don't draw any horizontal line first. In this the starting is, you will draw lines parallel to y-axis for integral values of x. That means at x-axis, of course, you will draw all the integers and you will draw a line passing through that. And you will make sure it intersects the graph wherever possible in that particular domain. The next is, now you are going to take the lower marked point x. So, of course, every x will lie between some n to n plus 1, no, where n is a number, integer basically. It will lie between n to n plus 1. Now what you do is, you take the point x is equal to n, the below point of intersection, and draw horizontal line to the next or the nearest vertical line formed by x of n plus 1. Example, you see that these are all x's. This is lying between minus 3 to minus 3 plus 1. So you will take the point of intersection of minus 3 here, and then you will draw a straight line vertical to the next line with the hollow. And that's all you have to keep on doing. Solid, hollow. Now this full x is between minus 2 to minus 1. You will take the lower one. You will see the point of intersection there. Draw a straight line to the next one, n plus 1 with a hollow. And this is how you keep on doing. And this is the graph of e of greatest integer function of x. The pink color. And black is e of x. Sorry, e to the power x. So I hope this session was useful to all of you. And soon I will be coming up with questions, how these things will be helpful in solving questions. So please go through. If any doubt, put your questions in your comment box. I will make sure to answer it.